Okay, so let's start by looking at the syllabus. And here is the syllabus for our class for Chemistry 3102. So we will be having lab lectures on Fridays at 12:15 p.m. right here on Microsoft Teams. Lab lecture is where we meet to discuss the upcoming week's experiment and all of the details pertaining to that experiment. And today we're just going to be doing a bit of an introduction to the course. And again, like I said, we're going to take a look at lab notebooks and what the expectations are there. So our class has been given approval to meet face-to-face or mask-to-mask, if you will, in the lab at Centennial Hall. And I'll go over the schedule with you so you know exactly when you are meeting. And so we are limiting the number of students that are in the lab at any one time. And there are no makeup labs on account of the pandemic. We cannot have makeup labs. And also, if you've taken a look at the schedule, you will have seen that we're doing less labs than usual. You'll have weeks off. And on account of that, there can be no missed labs in Chemistry 3102. All right, and there's no section for you to move to because every section is completely full. Anyhow, so this is Organic Chemistry 1. Again, we have lab lecture, which is section 001. We meet on Fridays from 12:15 to 1:30 on Microsoft Teams, where you are right now. Now, the lab sections, there are 4 sections, and 2 of them are taught by Mrs. Herring, 1 by me, and 1 by Mr. Mayer. And since each group or each lab section doesn't, break, the surnames don't break right through the middle of the alphabet, I've gone through and I've looked at all your last names and I've divided the labs up according to your surname. So let's say you were in section 030 and your last name began with the letter S, well, then you would fall under here and you would be in group 2, so on and so forth. Okay, so the labs are about 2 hours and 40 minutes long, and the lab lecture is 75 minutes. And some weeks that won't even take up to 75 minutes if we just have, some experimental details to go over. Anyhow, here is my information. So I am the lab lecturer. I am also the course director for the entire course. So the other lab instructors, they work under me in this class. So if you have any questions with respect to the class, you can email me. If you have any questions about the section, you can email those instructors and I will post their emails either in an announcement or I will add them to the syllabus. So required materials, you're going to need a textbook. The textbook that we use is Microscale and Miniscale Organic Chemistry Laboratory Experiments. We use the 2nd edition. It is written, or was written, I should say, by 2 faculty members from UCCS, Alan Schofsalt and Barbara Gaddis. Melvin Drulinger, I don't really know him. But anyhow, you can buy this book brand new at the bookstore, or you can buy a used copy somewhere. You can either look for one on Amazon or maybe on eBay or something like that. And so the lab text that we use, I'm just trying to get back here, looks like this. This is a copy of it. This is a soft cover copy. Come on. This is a soft cover copy that I have. So yeah, you can buy a hard copy. You can buy a soft cover copy. And if I can make a recommendation, this isn't a recommendation. This is more something you have to do. Before coming to class or before coming to the lab for group 1 for your first meeting, I'm going to ask you to read through pages 1 through 14 of the lab text. You'll want to read, it's only 14 pages. It won't take long, but you want to read pages 1 through 14 before coming to your first meeting in the lab where you get to meet your lab instructor. Anyhow, let me go back to my PDF here. Just give me 1 second. Okay, can everybody see the syllabus again? I'm trying to rifle back and forth.
Yes.
Okay, good. All right, so you need the textbook, okay, which again can be purchased at the bookstore or you can buy a used copy. In the original publication, there was a CD that comes with it. I suppose it still does come with it. You do not need that CD whatsoever to complete the class, okay? Anyhow, a lab notebook. So everybody needs to have a spiral lab notebook. You can buy one at the bookstore. You can either get 50 or 100 carbonless copies, and you will need that for this lab. And if you plan on taking Chemistry 3112, which is Organic Chemistry 2 lab, you can use the exact same lab notebook. You know, paper is cheap, and there's plenty of paper in there for 2 lab classes. Anyhow, so you need one of those. It says here that if you took a course that used these notebooks previously and you have pages left, like say you have one from an old course and you still have the pages left, you are more than welcome to use it in this class. Next, we're going to talk about PPE, personal protective equipment. Everybody needs to have, at a minimum, safety goggles, a lab coat, and nitrile gloves. You need to have your own gloves. If you go and ask your instructor for gloves, she or he will not have any extra gloves, so you need to bring your own gloves. So make sure to purchase plenty. You can buy them at a home improvement store like Harbor Freight or Home Depot, probably. As far as lab coat goes, they have to be long sleeved, and they have to be the ones that go below your waist to the mid thigh. So if you have one of those short lab coats like the pharmacists use, it will not suffice for this lab. What else? Plenty of nitrile gloves. Again, you're going to want to have more than enough gloves. You can buy them at the bookstore as well. If you spent any time looking at our classes Canvas shell, you probably noticed that there's a safety quiz in there. So there's a safety quiz, and you have to complete that safety quiz. It says here by January 25th. That's not accurate. I need to change that. The due date for the safety quiz, oh boy, I can't remember, but I believe it's February 8th is the due date for the safety quiz. I'm trying to pull it up here. Just give me 1 second, or maybe it's, no, actually it says it's January 25th, which is Monday. Yeah. Anyhow, so I guess, and I didn't set that date. That was set by the safety people at UCCS. Everybody who's enrolled in a lab at UCCS always has to take a safety quiz. So that's something to do over the weekend. And you have to get a minimum score of 18 out of 20. And before you get intimidated, it's not a long quiz. You just read through the safety training manual. It doesn't take very long. And you do the quiz. And you have to take that quiz. Otherwise, you can be disenrolled from the course. So I'll put that as a reminder, to put an announcement to remind you to complete the safety quiz by Monday. What else? There's some other information here about the lab, but we're going to talk mostly about safety in the actual lab when your group meets for the first time. Something you're going to want to be aware of are what are the expectations in the organic chemistry lab. Well, the organic chemistry lab can get quite dangerous. We work with plenty of dangerous chemicals in the lab, and so you need to know what you are doing before coming into the lab. You cannot come into the lab, open up your lab textbook and say, what am I doing today? Well, I'm going to mix this and this, I guess. No, it's not going to work that way. In fact, you are not allowed to bring the lab textbook into the lab. You will write out the procedure in your lab notebook, and you will use that procedure to do the experiment. And so that is why you're going to have a working knowledge of the experiment before coming to the lab. You're also going to need to keep a detailed lab book, perform common calculations, theoretical yield, and things like that. Understand the theory and principles of common laboratory methods. You're going to learn how to isolate and purify organic compounds, and you're going to learn how to apply the mechanisms that are learned in Chemistry 3101. Now, in many colleges and universities, organic chemistry comes as a package. If you enroll in the lecture, you're automatically enrolled in the lab. In fact, where I went to university, it was like that. When I signed up for organic chemistry lecture, I was enrolled in the lab. Well, at UCCS, the lecture and the lab are 2 different classes. So I know that many of you, in fact, most of you, are taking Organic Chemistry 1 with me currently. However, the 2 classes are not necessarily connected, okay? So I'll be lecturing about the lab in the lab and about the lecture class in the lecture class. All right. Anyhow, you can read through the rest of this. Let's take a look at storage of personal belongings in lab drawers. You can imagine that since we are in a pandemic right now, that there is no way that we can allow students to store anything personal in the lab right now. We're going to take attendance every lab. So if you do not make it to the first lab section, there is a short wait list for most of the lab section. So if you do not make it to the first lab, you will be disenrolled from the course. Okay, take a deep breath and let's talk about the lab notebook for a few minutes here. What do we mean by a lab notebook? Well, the lab notebook is what's going to document everything you do in the lab. Okay, it's going to document each one of the experiments. It's going to have your procedures in it. It's going to have your observations in there. Any calculations and conclusions will be recorded in your lab notebook. it should be detailed enough that another scientist who picks up this lab or a student in your class should be able to pick up your lab notebook and should be able to use your instructions to do that experiment. Okay? You're going to find that keeping a good lab notebook is a lot of work. There's no doubt to that. Okay? Or there's no getting around that. It is a lot of work, but it is imperative that you understand how to keep a good lab notebook, because if you are interested in getting a science degree, one of the things that you really have to know how to do when you get a science degree is how to write down a procedure correctly, how to collect data correctly, and how to interpret that. In fact, if you write a lab notebook in an industrial setting, it is a legal document. I spent most of my life as a bench chemist working in the pharmaceutical industry, so I wrote many hundreds of lab notebooks, and I can tell you that they were taken to court several times. So the lab notebook is a legal document. Anyhow, if you are unprepared when you come to the lab, if your lab notebook is not ready to go, if you don't have your pre-lab done, your lab instructor can ask you to leave. And the reason why is if you are unprepared when you come to the organic chemistry lab, you are really a safety hazard, okay? So it's not just that we want to look out for the safety of you, but for the safety of our other students. And so you have to come prepared when you come to the lab, and you have to know what to do. How am I going to know what to do? Well, you're going to read the experiment before coming, you're going to prepare your pre-lab, and you're going to attend lab lecture where I will cover a lot of the details of the lab and a lot of the pitfalls that you could run into while performing that lab. All right, lab reports. So you're going to write a lab report for each experiment. It says, as most anyone taking this course will have a science degree, in the future, you're going to find yourself in situations where you're going to need to convey your scientific results. And so we need to be able to write a good lab report in order to communicate our work to management. In this case, it's going to be the grader. It says here that oftentimes, if you were to work in a company where you are keeping a lab report, a company will oftentimes base its decisions on what is done in a lab notebook or what is written in a lab notebook. And so that is why we have to keep accurate notebooks and write good lab reports so that we are able to communicate effectively with the grader and with other scientists. All right, lab reports are going to consist of your lab notebook pages and data sheets. We will do some dry labs that will only consist of worksheets. Of course, you'll get more information on those as we proceed through the semester. Your pre-lab, normally before the COVID happened or before the pandemic, we used to collect the pre-labs from our students. We're trying to avoid, collecting anything that belongs to our students. And so what we're going to do is your instructor will come around and inspect your pre-lab at the beginning of the lab, okay, to make sure that you are ready to go. And then for submitting your lab, you're going to scan your lab notebook as a single PDF. So that's what collated means, one PDF, and you will submit that to Canvas, and I will provide a link for that, and then it will be graded online. So it will be graded remotely, and the reason we do that is to try to minimize contact between anything that we are touching and our students are touching. If your lab notebook is illegible, it will not be graded. It will be given a score of 0. And so the lab notebook makes up a big portion of your grade, and I'm going to talk about it even more today, and that's why it's very important that you understand the lab notebook requirements. Okay, late lab policy. If you end up handing or submitting your lab late, you can see the penalties here, and the penalties do accrue over weekends and holidays. If you submit only part of a lab report, well, we'll grade it, but you can only receive credit for the parts that you were able to complete. Again, you have to show up to all the labs. So if you miss the lab or have to miss a lab for any reason, please be sure to contact me and let me know. And it has to be some kind of reasonable excuse. If it's something like, it's my brother's birthday or something, that's not going to be an acceptable excuse. Anyhow, you can see here vacations, personal convenience, family trips or whatever. Those are not acceptable reasons. Anyhow, if you miss 2 labs for any reasons at all, even if you're sick or whatever, and you miss 2 labs, you'll have to be disenrolled from the class. And the reason why is because you have to complete a minimum amount of work in order to pass the class, okay? Here we have information about the withdrawal date, sitting during labs. That's something you'll talk about with your lab instructor. But generally speaking, when we're doing wet labs, we don't sit at all. in the lab, and we try to keep our labs clean. And this is something else that your lab instructor will go over with you in the lab, all the requirements for keeping the lab clean. We're pretty strict about that. And then keeping your work areas clean and things like that. Anyhow, here's the grade scale. Here's the course breakdown in terms of points. You can see that your lab reports and worksheets for dry labs make up the vast, most of your points come from that. You can see also that we have sapling assignments. So we have sapling online homework that everybody must enroll in. We have the sapling assignments are worth quite a bit, 35% of your grade. They are nothing to sneer at. They are not just, a 5-minute thing. They'll take you a few minutes to complete. So make sure you spend some time on those. If you look at our courses Canvas shell, I have a link on there and some information about the sapling assignments and the safety quiz that you must complete by January 25th. Okay, so January 25th, you have to have completed the safety quiz, and that is worth 5%. I can tell you right now that that's basically a free 5%, okay? And the reason we do that is just, you have to do the safety quiz. It's to really motivate our students to do that as quickly as possible. No cell phones in the lab. And again, your lab instructor will remind you if you decide to pull out a cell phone in the lab. We have a science center at UCCS. We highly recommend that all of our students take advantage of this free opportunity for help in organic chemistry. You can attend the Science Center virtually online through Microsoft Teams, and you can also go to the Science Center face-to-face or mask-to-mask in person in Centennial Hall. Either one is fine, and I will post an announcement about the Science Center probably this weekend or very early next week. You can read the rest about disabilities, military students, and that pretty much covers the entire syllabus. Are there any questions about the syllabus before we keep going here?
I have a few questions actually.
Sure.
So when you said we won't be able to store stuff in the labs, does that mean like in the general chemistry labs we had like cubbies for our backpacks and so on?
No,
we won't be able to use those?
No. Of course you have a place to put your backpack or your jacket. What that means is that you're not allowed to keep your safety glasses in your lab coat and your gloves in your drawer.
Oh, okay. And then when would the labs be due? Would they be due at the end of like the 2-week, like before your next lab, or would they?
No, all labs are due 1 week after the lab is completed.
Okay.
Yeah.
And that's it. Thank you.
Okay, no problem. Any other questions about the syllabus? And we're going to look at the schedule in Canvas, and we're going to talk about lab notebooks even more. When will the sapling assignments be due? All you have to do is open up the sapling homework online, and you can see all of the due dates for sapling assignments in there. So I would recommend enrolling in sapling immediately. If you can't afford to pay for it immediately, you can enroll for free for I think the first 10 or 14 days or something like that. So you can get started on it right away. And the due dates for each one of those assignments is in there. So the due date for every assignment, every sapling assignment is found in under this on sapling, which you would access through the sapling tab. Somebody asked, are we going to do dry labs in the off weeks when we're not meeting in person? Well, that brings us to the schedule. So here's the schedule for the semester. I've tried to color code it here. If you look at the red represents group 1 and the blue represents group 2. So if you're in group 1, you're just going to follow everything that's in red. The only exception would be what's covered in green here. So the green experiment, that's a take-home a take-home lab, and it's a dry lab, technique M and technique P that you can see right here. So that's the only one that's the same for every single person in the lab. But let's say you're in group A, for example. Well, your first lab, depending on whether you're in the Tuesday or one of the Tuesday or Thursday sections, you'll be meeting during the week of January 25th to the 29th. And then next week, we're going to be having no lab lecture. So there will be no live lab lecture. Then if you're in group B, you'd be meeting doing the exact same thing, the lab skills worksheet, during the week of February 1st to February 2nd. You might be wondering, what is the lab skills worksheet? Well, I will post that to Canvas before you go to the lab. I'll probably post it a couple of days before so that you will have plenty of time to print that out before coming to the lab. And whatever time is left over in the lab, you can work on it in the lab. And if you have any questions, of course, you could always ask your instructor. And if you're wondering, what is the lab skills worksheet? It's nothing more than a little refresher of some of the techniques and content that you would have learned in general chemistry lecture and in general chemistry lab. And then also there's a little bit of a scavenger hunt where you kind of have to look through the textbook and try to find some things in there to kind of familiarize yourself with that. All right. All labs are going to be submitted online. Every lab will be scanned, and you will scan it using your phone or a scanner, and you will submit it online as a collated PDF. So our first wet labs actually will, start here during weeks 4 and 5. We do an experiment about what's called TLC. Now that also falls on the time of the first spring break. You notice that, or you probably all are fully aware that there's 2 spring breaks, if you will, a long one and a short one this semester. So since there won't be any lab on Thursday, section 030 and 040 will not do that lab that week. They will do it during week 10. So it's just a little bit of an aberration there, and that's just because of the broken up spring break. So first experiment is about TLC, except for just those 2 sections who have to do it in week 10, which again, it's not my fault. That's because of the 2 spring breaks. So that's about TLC. Then we do another lab here, which is about melting points. So that's really fun. You get to melt a bunch of organic compounds in what's called a melting point apparatus, and the university has quite a few of them. So you kind of get your own melting point apparatus, and you get to try melting something. That's pretty fun. Next experiment, it says selection of an appropriate solvent to dissolve an organic compound intercrystallization. In this experiment, you'll get your first taste of what's called recrystallization in organic chemistry. It's a challenging technique. However, we set you up for the best possible route to success. We don't try to make it tricky or anything like that. We help you select the correct solvents and things like that. And then you'll see that also here in week 9, we're also going to have a dry lab that I will post that deals with IR, which is infrared spectroscopy, and mass spectrometry. And you'll have to do that at home. And we'll do a little lab lecture about that on March 12th. So something to look forward to there. Again, this is the 3rd time I've mentioned this, but 030 and 040 will do the TLC lab a little bit late. And again, that's because of the spring break. What else? Then we have a whole lab that deals with acids and bases, okay? I know that all of you took general chemistry too, and there's a whole section in that class that deals with just acids and bases, so just acid-base chemistry. And it's a really fun lab where we use the acid and basic properties of different compounds in order to do a separation. So basically, we separate compounds based off of their reactivities with acids and bases. Really fun lab. The next one, what do we do next? The next one deals with boiling points and what's called a refractive index. Now, I'm sure that a lot of you haven't even heard of a refractive index, but it's a physical property of a compound. And so I'll cover that in the lab lecture on April 9th. But that one, you get to boil something. So you actually set up a whole boiling point apparatus, and then you get to measure the boiling point. And you actually get to identify an unknown compound just by reading its boiling point. And since we live in Colorado Springs, you have to do a bit of a correction there. So that's kind of fun too. And then the very last exercise that we're going to do is a big one, which is what's called a combined spectroscopy. And that's where we look at what's called a nuclear magnetic resonance for carbon and proton. And then we also bring in some IR and some mass spec in that. So that's a big one. And that's kind of the last thing that you do before finishing up the semester, and there's no final exam. So again, if you look at the lab lecture schedule, you can see that some weeks we don't have a lab lecture, but we have lab lecture, I think, more often than not, or maybe around half of the time or something like that. Okay. And again, in those lab lectures, I will go over the techniques and again, some of the pitfalls and things like that. So somebody said, so your lab days depend on if you're in group 1 or 2. Absolutely. If we go to the bottom, you can see if you're in group 1, you do all the red, okay? Everything that's red, okay? If you're in group 2, you would do everything that's, highlighted in blue, okay? So that's how you're going to know what lab you're going to show up to. So some weeks you kind of have a week off. Now, again, a knee-jerk reaction might be for you to think, well, if there's more time, then I'm going to get 2 weeks to submit a lab. No, we like to have our students submit their labs within 1 week because we find that the grades are actually better if students submit their labs within 1 week of completing the experiment, because then it's kind of still fresh in your mind. You know, if you wait 12 days until you've done an experiment, almost half a month has gone by, and then you're like, what the hell did I do again? Yeah. So it's better to submit the lab sooner than later. So the deadline will be 1 week after you've finished it. It's going to be ready to go. All right. So let's go and let's spend some time talking about lab reports and formats. Okay, I'm not sure what this question is. It says, could you repeat what you said about labs 030 and 040 for week 10? Okay, so if you look at the schedule, okay, there are 2 spring breaks this semester. One is on February 17th to 19th, I believe, and the other one is March 22nd and 23rd. So March 17th to 19th falls in here, doesn't it? It falls in the week of the 15th to the 19th. So if you are on the 18th, which would be section 030 and 040, the school will not be open because there will be a spring break. So you will not be able to complete this lab, but you have to complete that lab. But don't worry, Mr. Dion thinks of everything, and you will complete this lab, experiment 3.7. You will complete it right here, okay? That's when you will complete that lab. If you are in that section, okay, 030 and 040 of group B. Maybe I should have put it in blue. Maybe I'll fix that, okay? Since it is a group 2 thing. But anyhow, that's what is going on there. All right, well, let's switch gears and let's spend the rest of our lab lecture. We've got 2 hours left. Let's spend the rest of the time talking about the formats for lab reports. And you'll notice that I included Chemistry 3112 in here. So this is good for Organic Chemistry 1 and Organic Chemistry 2. Before we go on, are there any questions? Anything at all? All right, does that clear up any questions about the scheduling? I hope so. Okay.
I have a question.
Shoot.
Is there going to be an organic lab too, or is it just this for both of the classes?
Nope. So this is Organic Chemistry Lab, Organic 1. So this is Organic 1 lab. And then if you want to take Organic Chemistry 2 lab, so this is Organic 2 lab. Okay, so both semesters of Organic Chemistry have a lab component. In Chemistry 3112, you do more syntheses, so you'd spend more time actually making organic compounds. All right, well, there we go. Just like in General Chemistry, you have General Chemistry 1 and General Chemistry 2. There's a lab for General Chemistry 1. There's a lab for General Chemistry 2. The same thing applies for organic. There's Organic Chemistry 1, Organic Chemistry 2, and there's a lab for each of them. All right, well, strap your skates on, Gordy. We're going in, and we're going to spend the rest of the time talking about what the expectations are for lab reports and the lab format. So first, let's talk about the reasons for a lab notebook. And I alluded to that already today a little bit, but let's review and let's kind of take our time on this. It says one of the goals of Organic Chemistry Lab is to develop skills in the proper preparation of a lab notebook. The lab notebook is a complete and permanent record of your experimental work. That means that everything you do pertaining to the lab before you go in, while you're there, and when you come out is going to be in the lab notebook. Okay, you're going to put a complete record of your experiments in there. A lab notebook has to be so thorough and well organized that if another student were to pick up your lab book, so if somebody else in this class was to pick up your lab book, they would be able to repeat the experiment, okay? And they should get the same result when they complete that experiment. So that's one of the reasons why when you write down your procedure before coming into the lab, you want to make sure that it gives enough detail so that, you know, you don't want to go in saying, well, I'm going to remember to do this and I'm going to remember to do that. You don't want to leave out any detail before you go into looking at the lab notebook. All right. Somebody says, will this document explaining the lab notebook and format and expectations be posted to Canvas? If we go over to Canvas right here, you can see where it says laboratory notebooks. What I'm reading from is the part that says lecture, Chem 3102, 3112 lab reports, and format Dion. So it's right in the middle of your page right now. So it is posted there already. Okay. So I have that, and I have a rubric. I have some sample pages. Anyhow, so I have a bunch of stuff on there. All right, syllabus and schedule. Okay. And then for week 2 and week 3, when you step into the lab, I have all kinds of stuff there about safety, and I will post the worksheet later. Anyhow, let's get back to it. So general guidelines. All data and observations must be recorded in the notebook in ink. It has to be either blue or black ink. You can't use any red pen or purple pen or green pen or all kinds of funky colors. I see students try. It's got to be either blue or black. And there is no reason for you to record anything on scratch paper in the lab. Every once in a while, I'll go over to the balance and I'll see a student, and I don't see this often, but a student with a torn up piece of paper. And I'll say, what are you doing? And they'll say, I'm writing down the mass, that I'm weighing currently. I'm going to write it down on the scratch piece of paper. Nothing goes on scrap paper. Everything is written in the lab notebook. If you make a mistake in the lab notebook, you do not scribble it out. So let's say you wrote, 18.0 grams, and you're like, no, it was supposed to be 28 grams. You don't do anything like that, okay? You never scribble. You simply cross out with a single line like that, okay? You do not scratch anything out. You just write a single line through it, make the correction. Make sure to leave a few pages at the beginning of your lab notebook for a table of contents, and keep that table up to date. I'm not going to be checking your table of contents, but that's for your own personal edification to help you find your way through your lab notebook. All right. Make sure your lab notebook pages are numbered. That's for your convenience and for your grader and your instructor as well. If they're not numbered, make sure to do that. It says here that if you really mess up a page, draw a diagonal line through it and start over on a new page. Put your initials on the aforementioned diagonal line. So look, let me show you. Let's say we had a lab notebook page that looks something like this, okay? I can give you 2 scenarios. The first one is if you just messed everything up. Let's say you wrote something in here, and it was all incorrect and you just botched the whole thing, okay? If you botched the entire thing, what you would do is simply scratch that out and you would put your initials like that. And that would tell the reader of the lab notebook that that there's nothing of value on that page. But if the reader did want to go back and look at it, the reader would be able to discern what you had written on there, okay? Another thing that you need to know is, let's say we have a lab notebook page like this, okay? Let's say this is a conclusion. You're writing up the conclusion. It's the last thing you're going to put in your lab notebook, and you've only got one more sentence that you need to write to finish up your conclusion. The rest of it was written on the page that preceded it, so you only have one line on there, okay? Then you've got an entire blank space on your page, like who's the blank space? Anyhow, you've got a Taylor Swift blank space on there. So what you're going to do is you're going to cross off the remainder of the page, and then you will put your initials on it like that. There's also a spot for you to sign and date at the bottom of the lab notebook pages, and your lab instructor will show this to you in the lab when you meet with your group. She or he will actually show you what the lab notebook pages look like, and you'll bring your lab notebook with you, and they'll show you exactly where you need to sign, okay? Start every new experiment on a fresh page. Always start on a fresh page. Paper is cheap, right? Paper doesn't cost a lot of money. So make sure to start all your experiments on a new page, and make sure to leave some pages in between your experiments in your lab notebook, okay? Any unused pages or portions, again, should have a diagonal line drawn through them, and be sure to initial that. Again, every page should be signed and dated. And you're wondering, are you going to check for that? Are you going to look to see if every page is signed and dated? The answer is yes, okay? Absolutely. We are going to check to make sure that you have signed and dated all of your pages in your lab notebook. Well, let's talk about the types of experiments that we might do, or that we will do this semester in the organic chemistry lab. We've got 2 kinds of labs, okay? We've got preparative labs, and we've got investigative labs. Another way that I would describe this is we have wet labs and we have dry labs. I think that's probably simpler and probably a better way to describe the types of labs that we do in Organic Chemistry 1 lab. Okay, wet labs are the labs, of course, where you're going to have your lab coat, safety glasses, nitrile gloves, hair tied back neatly, so that it won't fall into your reaction mixture or whatever. These are labs where we're going to carry out some kind of synthesis or, discuss a technique. Now, where I said investigative lab, I said that that's a dry lab. An investigative lab could be a wet lab as well. But an investigative lab is one where you study a particular technique. And to be honest, in this class, most of what you're going to do is just investigative labs. You're just going to be researching techniques. So I guess, maybe it's not the best description. But anyhow, you get my point, that there's kind of the two labs where we either synthesize something, that's more of a Organic Chemistry 2, and then we have the labs where we simply investigate a technique, and that's the lion's share of what we do in Organic Chemistry 1. All right, the format of these is similar. In the preparative, you're going to have a balanced chemical equation. You know what? You don't even really have to worry about that right now because it's going to be a while before we do any reaction or before we do any experiments where you're going to have to be concerned with a theoretical yield or a or any kind of reaction. Having said that, you might think, oh, well, I'm going to dodge the bullet and there's no calculations. That's not true at all. We will definitely be doing some labs like the boiling point lab and refractive index lab and the TLC lab where we will be doing calculations, even though there won't be any theoretical yield or percent yield or anything like that. Let's talk more about the pre-lab. Again, I just want to repeat myself since I see a lot of the same questions coming up over and over in the chat here. Your instructor will check your pre-lab when you come into the lab, okay? Your instructor is going to go around and she or he will look at your lab notebook to make sure that your pre-lab is ready. You're ready to go, you're raring to go, you know what to do, and you're not going to be a safety hazard to anybody in the lab or yourself, and you're going to be able to work efficiently, right? So these are things that have to be completed before you come to lab. All right, let's get into it here. The first thing is a header. The header is what we find at the top of the page in our lab notebook. So when you look in your lab notebook that you buy at the bookstore, there's going to be a header, a place to put your name and the date and the title of the experiment in your lab section. You're always going to have to fill that out with your name and the date and the experiment number and the title. Now, when it comes to the title, you'll probably notice that some of the titles of the experiments are a little bit long. On the first page, the very first page of your experiment, we want you to use the exact title from the laboratory manual, which is the same as the laboratory textbook. On the subsequent pages, okay, anything after that, you can abbreviate the title if it's particularly long, okay? Now, don't make it so short, don't give me a complete acronym or something like that, but you can abbreviate it after that. But again, if you don't want to lose points in your lab report, make sure that the full title is in the header on your first page, okay? And if you have any questions about what's a header, when you come to the lab for your first lab, whether you're in group 1 or group 2, what you could do? You could bring your lab notebook with you, show it to your instructor. If it's me, you could say, hey, Mr. Dion, what do you mean exactly by the header? If you've never even seen a lab notebook before, and I'll say, hey, here's where it is, and here's what you got to do, all right? So a header, after a header, we have a purpose, right? If you've taken any science classes since high school, you're probably familiar with writing the purpose of an experiment. What are you doing? And how do you intend to accomplish it? Okay. It says, don't blindly copy the summary of the purpose from the lab text. Think about, what are you doing and why are you doing it? Some other things that you're going to want to address. If you're using specific reagents, solvents, that are important in the lab, you're going to want to include those in the purpose. What if you're making a product? You're going to want to include that as well in your purpose. If you're isolating the product, now for some of you, you probably don't even know what isolation means yet, but that's something that we're going to cover throughout the course of the semester. But when you're isolating it, you're going to say, I isolated this by recrystallization. I isolated this by vacuum filtration, or it should be, I will isolate this by vacuum filtration. Anyhow, purification. You're going to learn a few methods of purification in organic chemistry. Characterization techniques. Those are things like boiling points, melting points, spectroscopy, spectrometry, things that we're going to look at further on this semester. And if you're wondering, is this the last time you're ever going to talk about a purpose, Mr. Dion? Of course not. Of course not. I'm going to talk about the purpose of every experiment when we do the lab lecture pertaining to that experiment. Am I going to give you a purpose for you to regurgitate? Not at all. Not at all. I'm going to give you some pointers, and then it's going to be your job to extract that information. This is a 3,000 level class. You're going to want to extract the information and come up with a purpose, okay? The purpose is only 2 or 4 sentences. This isn't going to take you a whole night to write this, okay? Don't make it into a procedure. Just keep it nice and concise, and you don't have to include anything about the order that you add the reagents. No procedures, no mechanisms, no structures, just the purpose of what you're doing. All right? Some questions you might want to ask yourself. You know, what are you making or doing? How are you doing it? Right? That's something. And those questions will be answered as we discuss the labs during the lab lecture. Right? How are you going to isolate your product? Let's say you're making a product. Okay? How are you going to isolate that product? Are you going to isolate it by an extraction? Are you going to isolate it by a recrystallization, et cetera, et cetera? How do you purify and characterize? These are the kind of things that you want to address. Again, when you're writing your lab report, if you're like, I'm a little unsure as to what Mr. Dion said about the purpose, what would you do? You could go back either to this video, which will be posted to my YouTube channel, or you could go right back to Canvas. You could open up this document and you could read it in its entirety. Okay? So we're not going to leave you out in the cold. The next thing is the table of reagents. So you got to include a table of reagents. What are you using in the lab? What are the solvents? What are the reagents? What are the products? Right? Why would you need to have a table of all the reagents? You could just say, okay, I'm adding 10 grams of sodium chloride and move on with life. Why do I have to provide information about my reagents? Well, the information that's held in the table of reagents is to provide you with the necessary information that you need during the lab. But if you've forgotten something, you know, oftentimes this has happened to me. I've written out a table of reagents, and you know, I'll need to measure something that's a liquid, and I didn't do the calculation ahead of time. But if I know the mass and I have the density in my table of reagents, well, there you go. You know, I'm going to be able to figure it out using the formula: density is equal to mass over volume. Volume is equal to mass over density, right? So that's kind of the way you want to think. You want to cover all the bases here. Anyhow, so you're going to list in tabular form the appropriate physical properties and quantities of each reagent, product, solvent. We're going to go over this in the lab lecture. If we're doing a lab, we're going to talk about what are the reagents, what are the products, what are the solvents. Mr. Dion's not going to leave you hanging. We're going to have good, fruitful discussions about these things. This is a partial list, just a partial list of some of the columns that you might have in your table of reagents: name, structure, molecular formula, molar mass, melting points, refractive indices, other properties that are applicable for that experiment. And of course, again, you know, I know I'm saying this a lot, but we're doing a lot of experiments. And so we'll talk about what the reagents are, you know, when we look at each specific experiment. Here's an example of a data table. This is one that was put together by a colleague of mine, but you can see there's some beautiful names and structures here on the far left. The scientist wrote down the name of each one of these compounds, and then he put the structures here. And keep in mind that for an ionic compound like sodium sulfate, you simply include the formula. Anyhow, let's take a look at these asterisks here. It says typical physical properties for the reagent or product. So this would be a reagent, benzoic acid, for example. Acetone is a solvent. It's also nail polish remover. Don't bring that to the lab, but anyhow. So that's a solvent. What would be important for a solvent? You know, a solvent is a liquid. The boiling point is going to be important, isn't it? The density is going to be important, isn't it, for a liquid? Whereas you notice that the scientist didn't include the density or the boiling point for benzoic acid. Why would she or he? Because benzoic acid has a melting point of 121 degrees Celsius. It's a solid at room temperature. So if there's a property that is not pertinent to the experiment, you can just leave it out of the table, okay? The next one, sodium sulfate, that's what we call a drying agent. And I'm going to discuss that with you later on in the class, what a drying agent is, but you can probably imagine that it's something that forms a hydrate when it comes into contact with water. Anyhow, So you can see the scientists left out every, property for the drying agent. Anyhow, let's move on from there. So table of reagents. You don't have to list the quantities of the reagents in the table of reagents. You're going to include that in your procedure. And if you're wondering, where am I going to find the information for the table of reagents? Where am I going to find all these reagents? Am I going to be looking on Wikipedia or asking Jeff Bezos or something like that? The answer is no. We actually have a list, UCCS chemical list, which can be found right here. You see in the middle of your screen, it says chemicals or list of chemicals for 3102, which is our class, and 3112, which is organic chemistry 2. Let's get back to the slides here. Remember, not everything is going to be used. We include what's important. Okay, in the interest of time, I'm going to move on from here, but we'll talk about that more when you get closer to when we do the individual lab lectures. If you have your microphone on, and somebody does, if you could mute that, please, that would be greatly appreciated. I'm not sure who it is, but somebody has their mic on. If you could turn that off, that would be grand. All right, let's talk more, and let's talk about something that's really important, and that is safety. Okay, you have to be sure that you have your safety table completed before you come to lab. And a little bit more on safety, it says you do not need to mention your gloves and eye protection or your lab coat because you're always going to have those on. Okay, there's no exception to that. For some labs, you might be asked to get more detailed information from an MSDS. In fact, you're asked to do that in the lab skills worksheet that you're going to do. That's going to be your first lab. In the chemical list, you're going to find safety information for each chemical, and be sure to list that. And bullet point is acceptable, but don't try to shortchange us or the grader on your safety table. Don't say, I'll just, write something really brief, dangerous, okay? Everything's dangerous. No, that's not going to cut the mustard. You have to be specific when it comes to safety. Safety is something we take very seriously here at UCCS. Next, this is only going to apply to preparative labs. You'd have to include a chemical reaction that shows the reaction that you're actually doing. Now, since you're just starting in organic chemistry, it's kind of hard for me to explain this. But basically, if you're doing, A plus B gives you C and D, this is where you include it, would be after the safety table. And you don't have to include what's called a mechanism. And if you're like, what's a mechanism? Well, we'll talk about that more later on. Hey, here's something that everybody knows from General Chemistry 1, limiting reagent and theoretical yield. If you're thinking, boy, I haven't thought about that in a couple semesters, you're going to be asked to calculate or do limiting reagent calculations many times throughout this class, and you're going to be asked to calculate theoretical yields many times throughout this class, even more in organic chemistry too, but maybe some, I'm trying to think off on the fly here, maybe a little bit in this class, but anyhow, you need to know how to do limiting reagent calculations, okay? Now, before you come into the lab, if you're doing a preparative lab, you would have to perform a limiting reagent calculation before you step into the lab, using as your quantities the quantities that are mentioned in the lab book. Now, let me give you a scenario. Let's say you had to go into the lab. Now, let's just take a deep breath here. Let's say the lab textbook said, I want you to weigh 100 milligrams of benzoic acid, right? You guys saw benzoic acid a couple slides ago, okay? Now, 100 milligrams is the same thing as 0.100 grams. Now, you have to weigh this out. This is one of the things you have to do in the lab. When you step up to that balance, you're not the only show in town. You're not the only person that's going to want to use that balance. There's going to be another student standing behind you going like, come on, hurry it up there, Mr. Dion. I'm waiting. So what are the chances that you're going to weigh out exactly 100, milligrams? I'd say probably very little, right? So what we're going to tell you is, Mr. Dion's going to tell you, you know what, you guys, as long as you get in the ballpark of 90 to 110 milligrams, that's good enough for this guy. Okay, so what you're going to do is you're going to mass that out quickly. Let's say you get 98 milligrams. Okay, you're going to have done the theoretical calculation, the theoretical yield calculation with the 100 milligrams. But now when you calculate your theoretical yield based off of your quantities, you're going to use the 98 milligrams. And if you're thinking, hey, Mr. Dion, all I'm doing is repeating the same math a couple of times. Yeah, that's right. Exactly. Okay, so you're going to do it a couple of times. Okay? All right. Look, again, it's important that you know that everything up to this point is going to be inspected by your instructor at the start of lab. Look, I can't stress this enough, you guys. We don't get a lot of, one-on-one time or face-to-face time with our students during a pandemic. It's one of the toughest things about being a teacher and a student right now, right? You guys all know that. But when you come into the lab, if you've learned anything or if you remember anything about today's presentation, you've got to be ready when you come to the lab. Okay? You got to be ready. You got to be ready. You got to know what you're going to be doing. You got to have your pre-lab ready. Okay? So that's the pre-lab. We're definitely going to check that. And we're also going to check your procedure. Okay? We're going to check your procedure. Are we going to read the entire thing? Probably not. But you can guarantee that your lab instructor has enough experience that she or he is going to be able to look at your procedure and say, this is reasonable or this is totally unreasonable, right? We want you to have a procedure that you're going to get from the lab textbook, and you're probably also going to get some points from me in the lab lecture. You're going to put it all together, make a beautiful procedure, all right, which is going to start on a new page. And it's got to be good enough that if you were to throw your lab book at another student in the class, don't do that. But if you were to pass your lab book to another student, she or he should be able to open that lab book and say, hey, look, this is Brooke's lab book. Let me open it up. Oh, look, she wrote a procedure. I can do this. I can follow this. I can read this. Number one, I can read it. And number two, I can do it, right? Okay, so you want to have a good procedure. Now, something that, I did a Google search the other day. I was looking at lab notebook pages. Now, the way we do things here at UCCS is different from how I did it when I was in university. I didn't use the 2-column format, but you've got your header on the top of your experiment page. And then on the page that you start your procedure, which is always going to start on a brand new page, okay? On the left-hand side, you're going to write procedure. Now I'm just going to abbreviate it, procedure. And on the right-hand side, you're going to write observations, and you're going to draw a line. I'm going to use blue because I said to never use another color but black or blue. You're going to draw a line down the middle of the page like that. So we call it the 2-column format, okay? 2 columns. And if you're wondering, why would you do that? Why wouldn't you just write it out like a normal sentence across, an 8.5 by 11 sheet of paper? The reason why is some really good reasoning behind that is because you write your procedure in bullet form, maybe step 1, 2, 3, 4, 5. Let's say that, you do step 1. You add 2 reactants to a reaction flask. Okay, your observation is, I stirred it, and it made a homogeneous solution. Yeah, interesting, but not super exciting. Nothing to really take a picture of and share with the class. But let's say step 2 is this. Let's say step 2 is you heat it up. Oh boy! All of a sudden you heat it up. This what was once a clear, colorless solution turns purple. Oh boy, so now you're going to write that down. So the reason we use the 2-column format is so that after every step, you can write down an observation. What the heck happened when I did this step? What happened when I did this step? Now, I'm sure there's somebody who's out there who's a great science student, and I know that science students love to get the maximum amount of work done for the minimum amount of effort. And you're thinking, well, come on, Mr. Dion, what if the step is, clamp this flask? That's not going to be very exciting. Well, if it's just some kind of menial task like that, you can just write complete or done or something like that. But something I want you to think about, just to kind of stew on, is what if I gave you $1 for every observation you wrote down? I bet you can come up with all kinds of beautiful observations. That, oh, look at that, there's a color change. It's generating some heat. Oh no, it's endothermic. It's becoming cooler. There's a precipitate. Look at the color of that precipitate. Right, so there's a whole plethora of observations we can make in the lab. Another thing that's great about observations, let's say another scientist went back to your lab notebook, okay, 2 years from now and said, you know what, Moira did this experiment, and I'm gonna repeat what she did. So let me see here. Step 1, do this. If the scientist does the experiment and sees the exact same observations as you, what do you think she or he's going to think? They're going to think, I am doing this correctly, right? Things are everything's going well. If I start doing the reaction and I get a purple, a purple solution, but the student didn't write that down, I'd start asking questions. Maybe the student forgot to write it down. Maybe I'm doing it wrong. So that is why you want to have a notebook that is a complete and thorough document. Anyhow, I'm probably making this a little longer than I need to be. Anyhow, again, the right-hand column, that's where you're going to put your right hand is your data and observations. The left-hand side is your procedure. You can number them. Personally, I like to number them. I've always kind of been that way. I worked in industry and wrote handwritten lab books for the first 7 years. I worked as a bench chemist, and that was just in industry. And I liked to write some experiments in number form, write everything down like that. I don't know. I don't know what this is right here. Anyhow, something that another thing I want everybody to know, okay, before we proceed, we're just kind of meeting each other today, is you are not allowed to bring the lab text into the lab. You can have it in your backpack or something in the cubby, that's okay, but you're not allowed to just open that up and start referring to it, okay? And if you're wondering, oh, Mr. Dion, you're a meanie, like why wouldn't you let me bring a textbook into the class? The reason why is because historically we found if we let students do that, too many students, not you of course, but other students would rely on that. They wouldn't take the time to prepare a proper procedure, and then just, all what would break loose. Students get in all kinds of trouble. If we just take a break, we got 15 minutes left in class. If we were to just take a quick break here, and I said to you, hey guys, I'm sure you guys are all excited about doing a lab or doing experiments in the organic chemistry lab, but who wants to get in a lab early? You know what? Most students will raise their hand like, yeah, I wouldn't mind finishing lab a few minutes early, have a little bit of extra, personal time. And there's nothing wrong with that. I would like to leave lab early too. What's the key to leaving lab early? The students who get finished usually the soonest are the students who are most prepared. If you put the work in ahead of time and you know what you're doing, you're going to walk into that laboratory with purpose, and you're going to know what to do. Okay? All right? So just things to think about. Okay? Preparation is key. So here's an example. It says weighed out 0.25 grams of benzoic in Erlenmeyer flask. What could I write down for an observation here? I'll just throw it out to you guys. Is there any observation I could make? You think if I weighed out a solid, it's obviously a solid, into a Erlenmeyer flask? Yeah, exactly. Good one, Moira. So Moira says the exact measurement, right? I said, what are the chances you're going to weigh 0.250? Let's say, so Moira, let's say we put in 257 grams. I was a little bit heavy, so we'll put that much was weighed. Is there anything else I could write down with that? Physical properties. I wouldn't necessarily include the physical properties because those would be in the, that would be in your reagent table, like the boiling point, the melting point. Somebody put mistakes. Well, if you were to make a mistake at this point on step number 1, I would just throw it in the trash and keep moving. So yeah, I wouldn't really worry about that. What about the color, right? What about the color of the benzoic acid? You could say it's a white solid, okay? But you know what? Powdered sugar is a white solid, and so is table salt, and they're different. Yeah, somebody put grainy. Yeah, exactly. I could write down it's a white crystalline solid. I could say it's white flakes, so there's any odors? Yeah, somebody put odors, absolutely. So these are the kinds of things that you want to think about. So I see that somebody put never throw chemicals in the trash unless your instructor tells you. Absolutely. I probably just said throw it in the trash, but throw it in the chemical waste or trash. You can always ask your instructor, where should I throw this before proceeding? And then dissolve in deionized water while heating. And of course, you could say, formed a homogeneous solution. You would report the temperature, all kinds of things like that. So things you want to think about. All right. Anyhow, there's all kinds of things written down here. So let's keep moving from there. We're running out of time. If the procedure was not part of the lab, students wouldn't read the procedure. Absolutely. So that concludes everything that you would prepare before coming into lab. Observations. You want to write down the best observations possible. I've already covered this to some extent, but you want to think about everything. Precipitates, boiling points, melting points, start, stop times, hot plate settings, something to think about. I guess you could go a little heavy on the observations, what color shoes you were wearing, what time of day it was, what the weather was like. That might be a little heavy. But anyhow, there we go. Well, during lab, remember you're going to sign and date every page on the bottom. Place a diagonal line through the unused portions. I covered that. Most labs are going to have some kind of calculations. they won't all have a percent yield or percent recovery. So we're going to learn how to calculate what's called an RF in the TLC lab. We're going to learn how to do corrections for refractive indices. We're going to do a bunch of different calculations throughout the course of the lab. And again, like one of my students pointed out, if you didn't use the exact quantities of reagents, you're going to want to make sure to redo your calculations using those values that you actually massed or measured in the lab. Make sure that your calculations are easy to follow. Be sure to include all units. I can't tell you how many times it looks like, and it is, I shouldn't say that, every once in a while, I'll have a student who will, put in a calculation that really looks like something they wrote on a napkin at Dairy Queen. They were just talking to a friend or something. You want to make sure that units are in there, not only to aid the grader when she or he is grading the lab, but also to help you, to not make any mistakes. You want to make sure that units that need to cancel, so on, and that you're using the correct units. All right. And virtually all of the lab notebooks all the labs that we do in this class will have some kind of data sheet that you're going to have to fill out. That will be a week by week thing. And of course, I'm going to cover that in the lab lecture for every lab. All right, results. So the results section usually consists of 3 paragraphs. The first paragraph, you state to the reader what you synthesized, including yield. So did you achieve the purpose? Did you actually make the compound? State any melting point or boiling point or things of that ilk. If you had an unknown, did you determine what it was? Did you identify the unknown? What was the process that you used to identify that unknown? Okay. The first thing I want you to consider about results, is that you don't want to just regurgitate your procedure. Okay. In your results and discussion, you're not just going to say, well, first I did this, and then I did that, and then I did this, and then I added this, and then I heated it, and then I stirred it, and then I took it, and then I extracted it. That's in your procedure. You will not get any points for that in a results and discussion, okay? That has nothing to do with your results and discussion. That is purely procedural, okay? So you don't have to regurgitate the procedure whatsoever, okay? In the second paragraph, you're going to use your experimental data to prove what you made, okay? And again, I'll go over this a little bit with you for every experiment in some way, okay? But let's say you were identifying a compound by its melting point. Well, how would you prove that? You'd say, well, I compared the melting point of my unknown to a melting point of a known compound from the literature, right? And then if I compare the percent error between what I measured for my unknown in the literature value, you can see that it's very small. And we're going to do a whole lab about melting points. But that is how you prove to the reader that you made what you made. You don't just say, well, the melting point was 102 degrees Celsius. It's got to be right. No, you're going to compare it to something that you know, right? How would you assess the purity of your product? Well, that's something that we'll address more when we discuss the melting point lab. But those are the kind of questions that you want to think of. Another thing it says here is don't comment about the yields, just report the values. Again, we're not going to be concerned with yields a ton in chemistry 3102, but just something that, myself and other instructors will discuss amongst ourselves. We'll say, well, this student said in their lab, the experiment went well. Well, I got a 50% yield. It went well. How do you know? What if the yield was actually supposed to be 90% and you only get a 50%? So it's best to be kind of mum's the word on comments on, the experiment went well. Lastly, you're going to state any experimental and physical errors that would affect product yields. If you were trying to isolate something and you couldn't isolate it, or your yield was really low, you would, really want to try to figure out why that happened. Do not simply say human error, okay? If you're looking for, an experimental or physical error, I spilled it. I dropped it. It fell over. It fell on the floor. Somebody else in the lab knocked it over with a binder. That is not an experimental error. Okay, that's not error. That's called a blunder. That's just screwing up. That is not an experimental error. You're trying to look for an actual inherent error, something in the experiment that could have gone wrong, not just spilling or dropping. Those are blunders. That's a screw up. That's a mess up. Okay. Statements to avoid in the lab report. first of all, you shouldn't be writing lab reports in the first person. I think the reaction went well. The word I should not be in a lab report. I added this. Other words, we should not be in there. I don't know what else, us, those are words that are not going to be used in a lab report. Okay. You don't say, I'm going to synthesize I'm going to recrystallize benzoic acid. I'm going to isolate it. You would say it like this. Benzoic acid will be recrystallized. It will be isolated, right? We don't want to putting our names, or somebody said Sally or John. I'm not sure what that means. But anyhow, we wouldn't want to use the personal, okay? We write our lab reports in the third person. All right, avoid abbreviations. Those can be a real annoyance when you're grading. They can, they can be really annoying. Anyhow, don't blame equipment or other people as errors. Look for actual sources of error, okay? Anyhow, oftentimes if our students really, and I mean really mess up bad at the beginning of an experiment, oftentimes your instructor can kind of help hold your hand a little bit to get you started again, but you always want to, report that to your instructor. Where am I? I guess that's kind of brings me to the end. Anyhow, some things to think about, and there's so many things that I'm probably, forgetting to say right now, things that I've left out, but that is why we meet in the face-to-face lab. It's so that your lab instructor, so we have two other lab instructors, Mr. Mayer and Mrs. Herring, myself, we can address any questions that you have in the lab. So what I would recommend is, since we're kind of running out of time here, if you have any questions about, what do I do exactly, what's going on, what's a header, what's this, what's that, you want to have that ready and ask that question when you come to the first lab. Because for the very first lab, there's very little that you need to bring. So somebody asked in the chat, they say, for our first lab, do we need to do these steps for the lab notebook? And the answer is no. Because if you look at the schedule, and let's look at it together. So let me bring it up here. Give me 2 shakes of a lamb's tail. Where's my schedule? Just give me a second. Schedule, here we go. So the first week, you're kind of not off the hook entirely, but all we're doing the first week is you're going to go to the lab. The first 2 weeks, depending on whether you're in group 1 or group 2, you're going to meet with your lab instructor. She or he is going to do a check-in with you. That's where you're going to go over the equipment that's in your drawer and in your kit, and you're going to make sure that everything is in there. You're going to talk about safety. Okay, so one of probably the lion's share of what you're going to do during your first meeting will be discussing safety with your lab instructor in the lab. That's why you have to be there for the lab. Safety is very important. We're going to talk all about MSDSs. We're going to talk about how to dress appropriately. What's an appropriate pair of goggles? What's appropriate gloves? What's an appropriate lab coat? If you haven't figured that out already, we're going to talk all about safety. Where's the eye wash station? Where's the fire escape? Where's the fire extinguisher? Do we have a shower? Yes, we do. Where is it? Right? We're going to discuss all those things for you so that before we start handling any reagents in the lab, we are all on the same page with respect to safety. And the next thing that you're going to do is on the time that's left over with your instructor, you are going to start looking at the lab skills worksheet. Now, I have not published this to Canvas yet, but I will publish it probably late this weekend or maybe on Monday so that you'll have time to print it out and bring it to your first lab. If you're in group 1, it's going to be next week. And if you're in group 2, it's going to be the first week of February. And again, just to reiterate, that's all you need to prepare so really all you need to do, if you want to really boil down to, or we're going to get it down to brass tacks, when you come to the lab, the first lab, all you have to do is show up. I would recommend bringing your lab coat, your safety glasses, and your gloves in case you have any questions as to whether they are acceptable or not. Your lab instructor will be able to tell you in a split second, yes or no. Okay, and then you'll want to print out the lab skills worksheet. If you want to start working on it before you come to lab, go ahead. If But if you have any questions about that lab skills worksheet, you're going to be able to ask your lab instructor, and she or he will be able to help you kind of get through that and say, oh, this is where you might want to look, right? Because I'm going to have some questions in there, again, that are going to pertain to this course specifically. Well, everything pertains to this course, but I'm going to have some good old general chemistry, redox questions, acid-base questions, questions about the lab text, okay? And another thing I want you to do before coming to the lab is to read pages 1 to 14 from the textbook, okay? It will take you only a few minutes to read 14 pages, okay? Everybody can read 14 pages quickly. All right? Are there any questions? Don't be shy. Where do I go back here? Are there any questions?
So for what we turn in on Canvas, are we scanning just everything that we write down, like the pre-lab and the results and all that?
Absolutely. So all the pages from your lab notebook, you're going to scan all those with your, of course, your header, your purpose, your table of reagents, your safety table, your reaction, if there is one, your calculations, your procedure, right? Everything that you did pertaining to that experiment in your lab notebook, you're going to scan it. Just use your phone. There are literally Avogadro's number of different scanning tools that you can use. And you're also going to scan the data sheet. So most labs that we do have a data sheet that go along with it, which I will publish on Canvas for everybody. And you can either fill those out. I publish them as docx files, so you can either complete those in Word if you want, or you complete it by hand neatly. Usually the only thing that we're kind of picky on that we like our students to do by computer, I'll be honest with you, and I was going to kind of wait for this, but I'll tell you today, it's 1:31, it's kind of late, but is the results and discussion. We usually want to have that typed, and it's advantageous to the student because when you're writing it, it's a lot easier to edit things when you're typing it compared to handwriting it. And just for your instructor, it's a lot of reading, so it's easier for us to kind of get through it and read through it. But yeah, that's what we mean by submitting it online. We've been doing it since since the pandemic broke out. I've been teaching organic chemistry lab, and our students have been submitting the labs online, and it works very well. Students are very good at submitting the labs online. Anything else?
I know some labs want us to underline or circle like calculated results or measurements. Do you want us to do that in this lab?
You can. It wasn't in my slides. I mean, you could ask your instructor. You could say, do you have a preference? I usually just, when my students include calculations, I like to look through the whole darn thing. If you want to circle them or box them in because it makes it easier for you when you look at it, by all means do so. I'm not really that much of a stickler about it. I find that by the time a student finishes general chemistry 2, they usually put everything that's an answer in a box anyway. Anything else? Yeah, so Hannah asked in the chat, she said, can we still type the results if we include it in the PDF? Absolutely. You just type it out, you can print it and scan it and add that to it. That's usually what students do. The students, generally speaking, like to type out the results in discussion. It's lengthy. It's the longest bit of text that you have to do, so it's nice to type that out. But it's also nice to get practice writing in a lab notebook when you're doing your purpose and procedure, table of reagents. Hey, another thing that just came to my mind, and there's a lot of things that I probably forgot to say, but something else is when you're writing your table of reagents, you're making a table. It's nice when students use a ruler to make the table. If you just try to draw straight lines, sometimes the tables can get a little wonky. Anyhow, if there's no further questions, so I've made some notes for myself. Go ahead.
Wait, I just forgot. I'm sorry.
No worries. Okay, so I've made a note for myself with a bunch of things I'm going to put in an announcement that I will try to post to Canvas today about sapling, just as a reminder for everybody to access sapling and get to work on that because there is a sapling assignment for your first lab. I'm also going to post some more information about my office hours and how to contact me, just so that you're sure. If you ever want to meet with me on Microsoft Teams, I'm always happy to do that. Some information about the Science Center, and also lastly, the safety quiz. Okay, so everybody has to complete the safety quiz. I would start that today. It doesn't take long. You just read through the whole safety manual, which is kind of relaxing, and it makes you feel safer before you step into the lab if you've completed the safety quiz. All right. And again, remember, the lab isn't a gotcha thing. It's not a gotcha, like I gotcha, it's not a thing where I'm trying to trick you. Every experiment that we do, we have a nice lab lecture where we sit down, we take a hard look at the experiment. What are we doing? Why are we doing it? What could happen in the lab when you're weighing this? And what could happen when you're measuring that? How would you correct for this? How would you correct for that? So there's a lot of questions that get answered in lab lecture. Okay. All right.
Oh, I also had a quick question. So with the sapling, has that already been charged, and have we gotten access through UCCS, or do we have to order that?
You have to enroll, and there is a fee associated with it. Okay, so you do not have access already. You can access it through Canvas. You can sign up for free, but I think the free trial only lasts 14 days.
So I just remember my question. Is there an example of like a good lab report that's going to be on Canvas at all?
Yes,
or anything like that?
there's one posted there already. Okay, if you look in, sorry, we're going way too long over time, but yes, there is an example of a lab notebook right here where it says laboratory notebooks. You see the last thing, it says tranexamic acid sample lab. Okay. So there's an example of what a notebook, a good laboratory notebook would look like. If we had had more time, I would have gone over that today, but it's a 3,000 level class. You can take the time to look through that. Okay. All right. Well, in the interest of time, we're going to wrap things up, and I look forward to meeting all of you in the lab. Even if I'm not your instructor in the lab, I'm going to do my best to at least show up a couple of times to your lab and introduce myself, because I think many of you have me as an instructor for Organic 1, so it's always nice to meet my students. All right, there we go. All right. Well, I guess I will see you soon, either on Monday or a Friday or the following Monday or something. But anyhow, I'll hopefully see you all soon. Have a good weekend, and I'm already looking forward to our first meeting in the lab. Take care.
Thank you. You as well.
No problem.